Today's session is about single variable calculus, polar curves. Here we shall discuss about angle between radius vector and tangent to the curve, angle between two curves, and pedal equations. First, let's see angle between radius vector and tangent vector. Polar curves are defined by points that are a variable distance from the origin, the pole, depending on the angle measured of the positive x-axis. Here, radius vector of a curve is the vector from the origin to the curve. The tangent to a curve at a given point is a straight line which just touches the curve at that point. Theta is angle subtended by radius vector. 5 is angle subtended by radius vector and tangent line, and ZSI is angle subtended by tangent line. If r is equal to f of theta, then the angle between radius vector and tangent is given by tan phi is equal to r times d theta by dr. Approach to solve. Step 1. Take log. Step 2. Differentiate with respect to theta. Step 3. Reciprocate dr by d theta. Step 4. Solve tan phi is equal to r times d theta by dr. Example 1. Find the angle between the radius vector and the tangent for the following polar curves. R is equal to a times 1 plus cos theta. Solution. Given r is equal to a times 1 plus cos theta. Step 1. Take log. Log r is equal to log a times 1 plus cos theta. Log r is equal to log a plus log of 1 plus cos theta. Step 2. Differentiate with respect to theta. Log r is equal to log a plus log of 1 plus cos theta. Log r is 1 by r times dr by d theta. Log r is 0, as differentiation of constant is 0 plus differentiation of log 1 plus cos theta is 1 by 1 plus cos theta times minus sin theta. Dr by d theta is equal to minus r sin theta by 1 plus cos theta. Step 3. Reciprocate dr by d theta. Dr by d theta is this. D theta by dr is equal to minus 1 by r times 1 plus cos theta by sin theta. Step 4. Solve tan phi is equal to r times d theta by dr is equal to r times minus 1 by r, 1 plus cos theta by sin theta. R and r get cancelled. 1 plus cos theta can be written as to cos square theta by 2, and sin theta can be written as to sin theta by 2, cos theta by 2. 2 and 2, cos theta by 2 and cos theta by 2 get cancelled. We get minus cot theta by 2. We know, if tan phi is equal to minus cot theta, then theta is equal to by 2, plus theta by 2. Angle between two curves. Let us draw two curves C1 and C2. Let O be the point on the intersection of C1 and C2. Draw tangent on curve C1 through this point, and draw tangent on C2 through this point. Let alpha be the angle between two curves. 1 the angle between radius vector and tangent to the curve C1. 2 the angle between radius vector and tangent to the curve C2. Angle between two curves is given by modulus of 5 to minus 1. Example 2. Find the angle of intersection of following pair of curves. Solution. Given these curves. Approach. Step 1. Find 1. Step 2. Find 2. Step 3 is equal to modulus of 5 to minus 1. Step 1. Find 1. First curve, this. Take log, we get this, according to property of logarithm. This can be written as log 4 plus log secant square theta by 2, and log secant square theta by 2 can be written as to log secant theta by 2. Differentiating with respect to theta, log r is 1 by r dr by d theta. Log 4 is 0 as 4 is constant. Differentiation of constant is 0. Here, 2 is constant. Taken out, log sec theta by 2 is 1 by sec theta by 2 times secant theta by 2, tan theta by 2, time 1 by 2. Thus dr by d theta is equal to r times tan theta by 2. Reciprocate dr by d theta. R will be 1 by r. Tan theta by 2 will be 1 by tan theta by 2, which is cot theta by 2. We get this. Solve tan phi is equal to r d theta by dr. R times 1 by r, cot theta by 2. Simplifying we get cot theta by 2. According to trigonometry of polar curves, if tan phi is equal to cot theta, then phi will be equal to pi by 2 theta. So here it will be 5, 1 is equal to pi by 2 theta by 2. Step to find phi, 2, curve 2 is this. Taking log, we get this. According to log property, it can be written as this. Log cosecant square theta by 2 can be written as to log cosec theta by 2. Differentiating with respect to theta, log r is 1 by r dr by d theta. Log 9 is 0 as 9 is constant. To log cosecant theta by 2 is 1 by cosecant theta by 2 times again differentiation of cosecant theta by 2 is minus cosecant theta by 2 cot theta by 2 times 1 by 2. Simplifying, we get dr by d theta is equal to minus r cot theta by 2. Reciprocate dr by d theta. Minus of r is 1 by r times reciprocal of cot theta by 2 is tan theta by 2. Solve, tan phi is equal to r d theta by dr. Putting the value of d theta by dr, we get this. Simplifying we get this. According to trigonometric property of polar curves, if tan phi is equal to minus tan theta, then phi is equal to pi minus theta. So here phi, 2 is equal to pi minus theta by 2. Angle between the curves, alpha is given by 5, 2 minus 5, 1. Substituting the values of 5, 2 and 5, 1 we get alpha is equal to pi by 2 which is 90 degree. Note, if angle between the curves, alpha is 90, it means curves cut each other orthogonally. Example 3. Prove that the angle of intersection between the curves this and this is 1 by 2 times pi plus cos inverse 1 by 3. Solution. Given curve r is equal to a, 1 minus cos theta and r is equal to 2 cos theta and alpha is this. Step 1. Find theta, equate both the curves, and simplify. We get theta is equal to cos inverse 1 by 3. Step 2. Find 5, 1 and 5, 2. Take log on both sides, and using logarithmic property we get log r is equal to log a plus log 1 minus cos theta. Differentiating, log r is 1 by r dr by d theta. Log r is 0 as is constant. Log 1 minus cos theta is 1 by 1 minus cos theta. Again differentiating 1 is 0 and minus cos theta. We get minus of minus sin theta, that is sin theta. That is dr by d theta is equal to r times sin theta by 1 minus cos theta. Reciprocate dr by d theta. We get d theta by dr is equal to minus reciprocal of r is 1 by r and reciprocal of sin theta by 1 minus cos theta is 1 minus cos theta by sin theta. We get d theta by dr this. Use formula tan phi is equal to r d theta by dr. Put the value of d theta by dr. R and r get cancelled. 1 minus cos theta can be written as to sin square theta by 2 and sin theta can be written as to sin theta by 2 cos theta by 2. Simplifying we get tan theta by 2. By the property of trigonometry of polar curves, if tan phi is equal tan theta, then phi is equal to theta. So here phi is equal to theta by 2. Now find phi 2. R is this. Taking log and by log property we get this. Differentiating, log r is 1 by r dr by d theta. Log 2r is 0 as 2r is constant. Log cos theta is 1 by cos theta. Again differentiating cos theta we get minus sin theta. That is dr by d theta is equal to minus r times sin theta by cos theta. Reciprocate dr by d theta. We get d theta by dr is equal to minus reciprocal of r is 1 by r and reciprocal of sin theta by cos theta is cos theta by sin theta. We get d theta by dr this. Using formula tan phi is equal to r d theta by dr, putting value of d theta by dr, and simplifying we get minus cot theta. If tan phi is equal to minus cot theta, then phi is equal to pi by 2 plus theta. Step 3, alpha is equal to 5, 2 minus 5, 1, substituting the values and simplifying we get theta by 2 plus pi by 2. Step 4. Substitute for theta. From step 1, theta is equal to cos inverse 1 by 3. We get this. Proved. Pedel's equations. Pedel equation. For a plane curve C and a given fixed point O, the Pedel equation of the curve is a relation between R and P, where R is the distance from O to a point on C and P is the perpendicular distance from O to the tangent line to C at the point. Pedel equation P is equal to R sin 5, or 1 by P square is equal to 1 by R square plus 1 by R to the power 4 times dr by theta whole square. The length of the perpendicular from pole to the tangent of the polar curve can be calculated with these equations. Approach. Step 1. Find theta. Step 2. Find 5, 1. Step 3. Solve using P is equal to R sin 5. Step 4. Substitute theta. Example 4. Find the Pedel equation for this curve. Solution. Given this, step 1, find theta. R square by a square is equal to 2 cos square theta. Cos theta is equal to under the root R square by 2 a square. Step 2. Find 5. Take log both side. By property of logarithm, it can be written as to log R is equal to 2 log A plus log 1 plus cos to theta. Differentiating with respect to theta, to log R is 2 by R, dr by d theta, log A is 0, as A is constant. Differentiation of log 1 plus cos theta is 1 by 1 plus cos to theta. Differentiation of this cos to theta is minus sin to theta times 2. Simplifying and rearranging, dr by d theta is equal to minus 2, sin to theta by 1 plus cos to theta. Reciprocate dr by d theta is minus reciprocate of R is 1 by R, and that of sin to theta by 1 is equal to cos to theta is 1 plus cos to theta by sin to theta. Using formula tan 5 is equal to R, d theta by dr, substituting the value of d theta by d, R and R get cancelled. 1 plus cos to theta can be written as to cos square theta and sin to theta as to sin theta cos theta. Cancelling 2 and cos theta, we get minus cos theta by sin theta, which is minus cot theta. By property of trigonometry for polar curves, if tan 5 is minus cot, then 5 is equal to pi by 2 plus theta. Step 3. Solve using P is equal to R sin 5, P is equal to R sin pi by 2 plus theta. This implies P is equal to R cos theta. Step 4. Substitute theta in P is equal to R cos theta. We got the value of theta in step 1. P is equal to R times under the root R square by 2 a square. Simplifying, we get P is equal to R square by a root 2. Example 5. Find Pedel equation of this curve. Solution. Given this, step 1, find theta. In this, bring a to the power m to left hand side. R to the power m by a to the power m is equal to cos m theta plus sin theta. Step 2. Find 5. Take log, we get this. Using logarithmic property, it can be written as m log R is equal to m log a plus log of cos m theta plus sin m theta. Differentiate with respect to theta. Differentiating m log R is m by R d theta by dr. M log A is 0 as A is constant. Differentiation of plus log of cos m theta plus sin m theta is 1 by plus log of cos m theta plus sin m theta. Again differentiating cos m theta we get minus m sin m theta plus differentiating sin m theta is m cos m theta. This implies dr by d theta is equal to rm cos m theta, sin m theta, whole divided by cos m theta plus sin m theta. M and m get cancelled. We get dr by d theta is equal to R times cos m theta, sin m theta, whole divided by cos m theta plus sin m theta. Reciprocate dr by d theta. R reciprocate becomes 1 by R, and this will become cos m theta plus sin m theta by cos m theta minus sin m theta is equal to 1 by R times 1 plus tan m theta by 1 minus tan m theta. is equal to I by R times, we know 1 plus tan m theta by 1 minus tan m theta is tan pi by 4 plus m theta. Using formula tan 5 is equal to R d theta by dr. Substitute the value of d theta by dr, simplifying, we get tan pi by 4 plus m theta by trigonometry property of polar curves. If tan 5 is equal to tan theta, then 5 is equal to theta, hence here, 5 is equal to pi by 4 plus m theta. Step 3, solve using p is equal to r sine 5. P is equal to r sine of pi by 4 plus m theta. Using sine of a plus b is equal to sine a cos b plus sine b cos a. P is equal to r times sine pi by 4 cos m theta plus sine m theta cos pi by 4. We know cos 45 and sine 45 is 1 by root 2. Plugging in the value here, we get this. Taking 1 by root 2 out, we get this. From step 1, r to the power m by a to the power m is equal to cos m theta plus sine m theta. Plugging it in above equation, we get p is equal to r by root 2 times r to the power m by a to the power m. Simplifying, we get p is equal to r to the power m plus 1 by a to the power m times root 2.